What questions can I answer off 5.7, page 79? 7980. Ew. How did I do 7? Let's see. State the critical value for a 95% confidence. What does this measure? Okay. So for problem number 7, being they said 95%, okay, state the critical value 95. All right, so I'm just trying to think, where did that come in? All right, so think about this. So state the critical value for 95% confidence. So the region in between here is 95%, okay? Which means that I have 2.5% over here and 2.5% over here. Agree? Because if I add that all up, I get to 100%. So what I'm going to do is I want to find this. Okay, so going all over. So we're basically looking at the 97.5% is the area we're looking for. So if I do normal CDF, let's see, straight. Did this go with a question? Oh, it's not normal CDF. It's inverse norm. And we're going to plug 0.975 in. And if we do this on the calculator, it's going to come out to 1.96. Okay, so this means we would need to be 1.96 standard deviations away from the mean in order to capture 95%. So if here was our mean, this would have to go out to 1.96, and this would have to be minus 1.96 from there. And if we did that, that captures 95% of the whole thing. So we kind of use the normal curve originally, realizing that we have the tails of the 2.5, realizing we have to have that 97.5. This is that halfway to 100. Okay, so if I did the halfway to 100, I'm 5 away from 100. 5 divided by 2 is 2.5, so we'd have to add the 2.5 to that. This is another way of thinking about it. Is that okay? What else did I see? What else can I help you with? We all seem okay? Going once, going twice? All right. All right, so friends, this week I have planned, let's see, so today we will do 5.8. Then we're going to make sure we really review 5.6 to 5.8. And then we have a quiz on Wednesday from 5.6 to 5.8. Now, we are supposed to get snow Tuesday, Wednesday. Fingers crossed we could get a snow day. Still with me? We could get 2 snow days.
Yeah.
All right, so let's pretend both Tuesday and Wednesday become a snow day. Yeah. That just means what Tuesday and Wednesday were, we'll move to Thursday, Friday. You with me so far on this? Sure. If one of those days is a snow day, we would just adjust the schedule down. Okay? So,
video class?
What's that?
We do a video class.
No, if it's a snow day, we're.
No, I mean like you
no, they're just gonna have us drive.
And then
Almost died, you know?
Yeah,
I really
And then,
I didn't mean virtual class.
no, I wouldn't do that. I hope never to have to do a virtual class ever again. I hope never to do Zoom classes or Teams or. Oh my gosh. You know why they were terrible to me? Everyone's camera was off, and I'm sitting there just talking, and I have no idea if anyone's even there. And being I have freshmen, I know a great deal of them would say, turn it on, and they'd leave. They'd be playing, some video game. And how I know they were gone is like, Billy, you still there? Billy, class ended 10 minutes ago. Billy wasn't there. So just kind of a silly with that. So friends, I am on the wrong page. So 5-7. I am on page 16 of the books now. Page 16 of this book. So we are talking about one mean z interval. Now again, friends, you can have multiple means, which kind of sounds weird, but we won't ever get into it. So this is 5-8. Okay. It says a one mean z interval is a very simple structure to a one proportion z interval. However, the sample means have a different standard deviation procedure as outlined by the formula below. Standard error. So SE is called, what's that? Yeah, if you just walk in my office, you'll see it right there by the door. Okay, so this is, oops, I want that. Standard error. This is sigma, which stands for the population standard deviation. And then n is the number of people, the number of items or whatever, the number tested. Okay, so where this one is used more often, ACT test has been given a lot. They have a lot of data. So from a lot of data, they've come up with, basically what the average is, or the mean, aka mean, and the standard deviation. So rather than redoing it, then they might, let's say they take this year's average and they take a look at it. They apply it back to the overall of 20, 30, 40 years, or however long the ACT has been given, mean. And so when we're looking at the population standard deviation, we're taking into account everything. So a lot of times that's given. And then we want to check to see where our standard error would be, or how close to the mean we would be. Okay, so once again, the Greek symbol sigma stands for the population standard deviation. We must know the population standard deviation to create this confidence interval. So this is going to be when we are dealing with, hey, we have a whole bunch of data from years past. Now we're going to apply it to this year's data. So the point estimate is simply this is the sample mean. The margin of error, MOE they call margin of error, Mo, I like Mo, becomes a critical value and is multiplied by the standard error of the mean. So this is going to be Z star standard deviation over root n. Okay? So this is our Z-score. And a Z-score, again, can be like a standard deviation that we can find. A standard deviation, doesn't have to be a whole number. Z-scores account for the other things. So the example they're giving, the Z-score is also found by doing the inverse norm. But remember, if we have a certain confidence interval, then we have to remember we have the tails at either end, so that's halfway to the 100. Okay, example says a company develops a test of leadership skills. Yep. This is exciting. This test is given to 50 applicants for a job. Okay, so we have 50 applicants. Okay, that's not apps, that should be applicants. The average test score is 84. So that is our mean that's given. Assume that the test developer knows the standard deviation for all these tests is 12. So this is all standard deviations. Okay? create a 90% confidence interval to capture the average test score. So we want a 90% confidence interval. So we need to figure out what we're going to plug into the inverse norm. Okay, 90 is how far from 100? 10. 10 divided by 2 is? So I'm going to make this 95%, which is 0.95. And anyone have a calculator that available? Why do you do it 95? Okay, so we want a 90% confidence interval, which means this. Okay, so what we're trying to do is we're trying to capture 90% of our stuff. But really that 90% comes here. So when you go, what you have to remember is the 90% is here to here. I want to accommodate these people down here. So 5% of my population's here, 5%'s up here. So 90 plus 5 is 95%. So the 90% is just, hey, this is the area here, and that shifts. But if I want to account for the tail this way or the tail this way, I need to realize how far from the 100 I am. And so if it was a 99% confidence interval, 99 is 1 away from 100 divided by 2. So then you plug in 0.995. It's inverse norm. We good so far? All right, let me pull up my calculator real quick.
What would we use the standard error procedure for?
Where are you looking?
The first part of the part?
Well, but it asks on the whole report, it asks considered it.
Yeah. This is coming up. Come on, baby. All right, so second, distribute inverse norm. And we said it was 0.95. And then we're not worried about the information that's given. We just plug it in. It'll still work for us. So that comes up to 1.64. Okay, so 1.64. Wow, I don't know how my calculator already had that, but so be it. So that means that I'm going to take this. I'm going to go 1.64 times the 12, which is our standard deviation for all scores. And then we're going to say we had 50 applicants. And if you went and did this math here, you're going to come out to 2.79. Okay, so that means this. If our mean is here, we'd have to go out plus 2.79 or minus 0.279 from the mean in order to capture. This would capture 90% of the population. Okay? Now what this means is we are 90% confident that our estimate of 84 is accurate to within 2.79 test points. Okay, so pretty good confidence interval. So the confidence interval, if we wanted to figure it out, is going to be our 84 plus or minus the 2.79, which is going to be from 81.21 to 86.79. So again, we're 90% sure that if we redid this test using all the same parameters, we're 90% sure our data will fall within that. Okay? So there is possibility it falls outside of it, but we're 90% sure, so that's kind of telling the reader. So that is, we're 90% confident that the true average leadership test score is between 81.21 and 86.79. Okay, so with that known, I guess, so now we're doing the inverse T. Let's see, we're on 5.8, right? What did I just teach? 5.8? Can't see my board. So let's get a good start on page 81, 82. Happy to help you on that if you need any help. But I'm going to stop my recording there. Sound good?